Follow-up discussion on Stats.blue. Now we are going to pick up a random variable and then we are going to test the assumption as such. Let's take the normal random variable. I will click on this. Let's say in the hotel, the average delivery time is that when we place an order, we get the food in 15 minutes. And then there is a standard deviation of 5 minutes example. Let's say we have tested with 100 customer and we can keep only one decimal is enough. So it has given that various data points, right? First is 17.4 minute all the way to 12.8 minutes. So what I'm going to do is that I'm doing it in mobile. I'm just copying this data and go back and I will keep it here. This is very beautiful to check the normality test. You can just click here and paste the value here. So I'm going to paste this value. All the value is being pasted, and if you wanted to keep it as a frequency you can keep, but if you wanted to add any other extra column you can keep it. But we have kept all the values in the same subgroup or same column. And data is normally distributed, there is null hypothesis, and then alternate hypothesis is data is not normally distributed. Level of significance we want 95%, so it gives different options, so 95% is good. And then number of simulation is going to do it on 1000. That's a very minimum value we have. Then calculate this value. You can see that it has given the normal probability one. All the values are much inclined to that slope line, you can see here. And then you can also see that the correlation value, simulation of standard normal data sample, so how the value is being slightly skewed on the right side. So it also gives that number of data points is 100, and it also gives the regression line y equal to mx plus c. The correlation value is strongly correlated 0.98 critical value, and then we want that p value. P value is 8.2%. When you say 8.2%, that means data is normally distributed, right? Because it is greater than 5%. So you can see it is also given that interpretation under the assumption of normality, the approximately probability of seeing a normal probability plot, correlation is as small or smaller than this value. This is to say that the level of significance, the test does not rule out the possibility that our data come from the normal distribution. So conclusion, keep the null hypothesis. That means data is normally distributed. So it is opposite to the other hypothesis. Here we need p value greater than 5%. Generally in other tests of hypothesis tests we need less than 5%. I hope you find it useful.